Like this. Good morning, everyone. So today we are going to discuss about the last topic of first unit, that is organometallic compounds. So let's see the definition. So what do you know about organometallic? What the term implies? So this term organometallic compound implies that a bond forms between the metal and organic species. So particularly that organic species may be alkyl part or aryl part or cycloalkyl part. So whatever it may be. So the compound in which a metal carbon bond is formed, more likely R bond M. R means alkyl part. So here I shown that R as alkyl, and it may be aryl part or it may be alkyl part, cyclic compound, whatever it may be. So such compounds are known as organometallic compounds. So generally organometallic compounds, particularly a part of transition metals, particularly lithium, magnesium and aluminum, are most amongst some of the most important organic reagents. So we have a number of organometallic compounds. Probably the transition metal atoms has we have organometallic compounds abundantly given by transition elements. A part of transition elements, main group elements like S block, P block elements generally considered as main group elements, particularly in that S block and one means that means first A, second A, third A groups. These groups may have only metals, so these group elements may give organometallic compound. In such we have particularly three. One is lithium organometallic compounds, magnesium organometallic compounds. So generally magnesium organic metallic compounds already we have studied in lower classes under the name of Grignard reagent, RMGX, and another one is aluminum. So aluminum in the next organic second unit in organic chemistry we will discuss about this aluminum. So aluminum will, also has gives some organometallic compounds, particularly those are used as reducing agents for the reduction of acids and other derivatives to get aldehydes and ketones. Okay, so now today we are going to discuss about the preparation and the chemical properties of lithium and magnesium organometallic compounds. Okay, in next organic chemistry we will discuss about the aluminum organometallic compounds. Okay, so organometallic compounds provides a source of nucleophilic carbon. So if you just recall the basics, whatever you have studied in last year in organic chemistry, particularly carbocation, carbanion, carbanion, all those things. So most of the cations, carbon compounds are alkyl part may get the positive charge. So those are known as carbocations, and the very few, particularly if you say the organometallic compounds, in that organometallic compounds carbon will get the negative charge. Okay, so that's why these organometallic compounds are used as a nucleophilic centers, particularly in organic reactions. Can react with electrophile carbon to form a new carbon-carbon bond. So in next slide we will see how these organometallic compounds are used in organic chemistry. Okay, next one is to rationalize the general reactivity of organometallic compounds. It is convenient to view them as like this. So generally, to better understand the about the nature or the charges, whatever charges arises in that organometallic compounds. So those are shown like R minus and M plus. So that means we have shown organometallic compounds in its ionic form. Next topic is nomenclature. So how we name the organometallic compounds? For example, how we name? So just like alkyl metal halide, like that. So for suppose, if you look at this one, CH3Li. So generally what we do, methyl lithium. So this is Grignard reagent, methyl magnesium bromide. So as like remaining compounds here also we follow same nomenclature principles. So first we write the name of anionic part followed by the cationic part. For example, if you take NaCl, what is the name of NaCl? Sodium chloride. So in that Na plus and Cl minus. So just here we reverse that form. Okay, in organic chemistry, first we write the name of the alkyl part followed by the metal part. Okay. Next, physical properties. What are the physical properties of these organometallic compounds? So organic metallic compounds are usually kept in solution of organic solvents due to their higher reactivity. So generally these organometallic compounds are stored in, particularly if you say non-polar uh, organic solvents, but like diethyl ether or CCl4 like that, or THF tetraethyl, not THF. This is what is that? Ether, diethyl ether, benzene like that. Why? Because if we store or if we keep this organometallic compound in polar solvents like water, what happens immediately? The water has a weak acidic in nature, so this R part will react with water to give rise RH, alkane, and that liberates oxygen gas. So to avoid this reaction, generally what we do, we keep or we store the organometallic compounds in particularly non-polar organic solvents. Let's see the structure. Okay, see here, this is the methyl chloride part. So this is alkyl halide. It is not a compound, organometallic compound. This is alkyl halide, how it appears. So this blue region is denoted as methyl part. This is carbon and these three are the hydrogen atoms and this is chlorine. And due to higher electronegativity, what happens? The electron density generally partially displaces toward the chlorine. So that's why this part will get the partial negative charge and this part will get the partial positive charge. Likewise here also the methyl lithium. So in that methyl lithium, what happened? The trend is reversed. Why? Because the lithium is a metal. So obviously metal has less electronegativity than carbon. Carbon is a non-metal. So now this trend is reversed. So the electron density is displaced towards whom? This alkyl part. So that's why this alkyl part will get the partial negative charge and this will get the partial positive charge. And this is methyl magnesium bromide. So here also same thing. So this is the magnesium and this is the alkyl part and this is the bromide part. So this bromide part has more electronegativity. So that's why the bond pair of electrons displaces partially towards the bromide. So that's why this bromine will get the partial negative charge. And here also same phenomena we can expect here also. Why? Because the carbon has comparatively bromine, carbon has less electronegativity, though it can attract or it can pull the bond pair of electrons towards it. So that's why it will also get the partial negative charge. So this is about the structure of organometallic compounds. And next see. Okay, so this is the image shows that electrostatic potentials of methyl chloride and methyl lithium and Grignard reagents, all those things. Okay, next preparation. So how we can prepare this organometallic compound? So here I'm showing a common method which is used to prepare alkyl lithium as well as Grignard reagent. Okay, and we also discussed the similar reactions of organolithium and Grignard reagent. Okay. So we have a number of methods to prepare the organometallic compounds. So I kind only um, similar reaction here. So this alkyl halide, this is alkyl halide part. So whenever this is treated with lithium, what happens? The lithium is a metal, so the metal has a tendency to lose the electron. So the whatever electron released, that will be taken up by whom? Alkyl part. Why? Because in this bond RX bond, so here see if you recall the structure of this one, so this is alkyl part, this bond is what? It is somewhat weak. Why? Because the bond pair of electrons are pulled by whom? And this chlorine atom. So that's why it gets the partial positive charge. So it is electron deficient. When it has an electron source, then what happens immediately? That electron source feasibles the bond breakage. So that's why when this bond is broken, so it will be eliminated as X minus Cl minus and it will get the complete charge. So this charged part will readily accept the electron from lithium. So we will get the RLi bond. So at the same time, one more atom. So another lithium atom will release one more electron. So to uh, uh, form a ionic bond with this, and one first lithium will have it will donate its electron, and thereby it will be get positive charge, and this will be become as lithium halide. And second lithium, so which doesn't donate the electron, but already one lithium is donated electron to the carbon, so that's why this carbon part become as free radical. And another lithium, so if you recall the electronic configuration of lithium, so 1s to 2s1, so the second electron and this free radical will form a covalent bond, so that results the formation of RLI. So here X means those are the halides: iodine, chlorine, iodine, bromide. Okay, so let's say the reactivity. So which halides can promote the this reaction? Here, these halides are act as a leaving group. So leaving group. So the more strong leaving group, more the reaction. So if you compare the reactivity of leaving group tendency, or we can say reactivity. So iodide has more tendency to leave the more tendency to leave left by taking one electron from the alkyl part. So iodide has more reactivity than bromide. Bromide has more reactivity than chloride. If you here the R part may be alkyl part, vinyl part, or aryl part. So if you consider the nature of the alkyl part, so we have the different types of alkyl parts: primary carbocation, primary alkyl part, secondary alkyl group, tertiary alkyl group. So which is more reactive? Obviously tertiary alkyl part is more reactive. Let's see here. See again, this typical solvent are normally used anhydrous diethyl ether. So here again we used anhydrous. Why? Because when we have the water molecule, what happens? This part immediately reacts with water and they convert the alkyl part into alkane, RH, and it will be lithium hydroxide. So to avoid that reaction, so generally we store this alkyl lithium as well as a Grignard reagent in anhydrous diethyl ether, or you can say ether also. Okay, so this is about the preparation of organolithium. In similar manner, we prepare magnesium RMGX. So here in that part happens, just we insert the magnesium in between alkyl part and halide part to get RMGX. So again here this reaction is carried out in presence of ether. Again that is anhydrous ether. Why? Because it is the best solvent to store the Grignard reagent. So this is another form. So this R part may be a cyclic part. So when we use the cyclic bromide or cyclohexyl bromide, then we can get cyclohexyl magnesium bromide. If it is a vinyl part, so we will get vinyl bromide. Or if you use phenyl bromide, then we may get phenyl magnesium bromide. Okay, and same reactivity, same thing. And again, so this is tetrahedron furan. This is known as one more solvent. That is, we can say, aprotic solvent, that is denoted as THF, tetrahydrofuran. So generally we store Grignard reagent as well as organolithium in diethyl ether as well as in tetrahydrofuran. Next, let's see the properties. So both are in Grignard reagent, that is RMGX and RLI. This alkyl part will get the negative charge, and this part lithium part will get the positive charge. Likewise here also this magnesium halide also gets the positive charge. Okay, so let's see. So whatever it may be, whether it is lithium aluminum or lithium magnesium halide, whatever it may be, so when these are treated with carbonyl compounds, we may get alcohols. So how? Later I will show you the mechanism. So first step, it is attacking of alkyl part on carbonyl carbon. So why? Because here the alkyl part of this organometallic compound acted as a nucleophile. So when we have nucleophile in the reaction medium, so the counterpart should have electrophilic center. So here the electrophilic center is okay. I will show you with pointer. Okay, so this is the carbonyl carbon. So this carbonyl carbon, here we have carbonyl carbon and here also we have the carbonyl carbon. So this carbonyl carbon acts as a electron deficient center, or you can say electrophilic center, and here this alkyl part acts as a nucleophilic center. So this nucleophile attacks on the electrophile. So then what happens? That simultaneously what happens? These electrons completely shifted on oxygen. So thereby this oxygen will get the negative charge. So that will show you. I will show you in next slide. I will show you the mechanism. So here see, when these carbonyl compounds are treated with organometallic compounds followed by the hydrolysis, they result alcohols. So see, the formaldehyde with RMGX or RLI gives the primary alcohol, whereas other aldehydes except formaldehyde. Remaining all aldehydes, whenever treated with RMGX or RLI, followed by the hydrolysis, will give the secondary alcohols, whereas all ketones will give the tertiary alcohol. So that is the difference, and it is one of important reaction also. So by using this, we can get these three type of alcohols: primary alcohol, secondary alcohol, and this one is tertiary alcohol. Okay, so let's see the mechanism. So this is the mechanism. So just now, whatever it may be, whether it may be RMGX or RLI, this alkyl part acts as a nucleophile. So this nucleophilic center always attacks an electrophilic center. So here the carbonyl carbon acts as a electrophilic center. So when this nucleophile attacks on the electrophilic center, that accompanies complete shifting of bond, this pi bond onto the oxygen. So thereby what we get? We get a negative charge on oxygen, and this part will get the positive charge, and so that will be attached to the oxygen. So thereby we get a salt. It is known as salt. And next, this is hydrolysis. And during hydrolysis, just breaking this bond. So H will be we place towards the oxygen, and OH will be placed towards the MgOH. So thereby this bond completely broken, so we get the alcohol. So this is the step mechanism. This is the mechanism. So the first reaction and important reaction is one reaction of RMGX with aldehydes and ketones. So that will give the alcohols. Already I think you might have studied in second semester, that is the preparation of alcohols. Okay, so this is the mechanism. Next step, ring opening of epoxide. So I think you have studied these epoxides also under the oxygen compounds, epoxides. So here also same thing. So this alkyl part acts as a nucleophilic center, and either of this carbon can act as a electrophilic center. So R will be attacks here, and then what happened? The complete shifting of this bond upon oxygen atom. So thereby again acidic hydrolysis, that will give the alcohols. So that means we can prepare the alcohols with carbonyl compounds as well as epoxides also. So it is which type of reaction? SN2 type of reactions. Again, so and same we can kind similar type of reaction mechanism. Okay, second step is same. So first step is somewhat different. So in first step, what happens? This alkyl part attacks on this either of this carbon. So thereby the shifting of bond takes places toward the oxygen. So that results the formation of salt. And second one is acidic hydrolysis. So acidic hydrolysis yields our desired product. So this is with epoxides, and next one is with esters, reaction of alkyl halides and RMGX with ester. So see, this is the ester, and similar reaction we can expect here. So this is carbonyl carbon, or sorry, this is carbonyl carbon, and this is the electrophilic center, and these are nucleophilic centers. So when this nucleophilic centers attacks and the electrophilic center, what happens? The bond shifted completely on oxygen again. It will shift again here, then we will get what happens, this OR will be eliminated. So let's see in the reaction mechanism. So this is reaction mechanism. When this alkyl part, or you can say carbon ion, whenever it attacks on carbonyl carbon, what happens? The double bond completely shifted on oxygen. So thereby we will get like this structure salt, and again the lone pair of electron again shifted here. Then what happens? This part will be eliminated as alkoxide or ethoxide, O minus. So minus, that results the formation of ketone, and similar reaction we can expect as in case of first thing. So reaction with aldehydes and ketone. So again it has, again we have one more nucleophilic center, that is again one more RMGX will attack on carbonyl carbon. Again why? Because again we have one more electrophilic center. So again that displacement attacking results the displacement of this pi bond onto the oxygen atom. So thereby again we get a salt, and further hydrolysis of that salt, again we get what? Tertiary alcohol. So in this reaction, first what we get? So when we treated RLI or RMGX with ester, first we get a ketone. Further, that ketone undergo again the reaction with the same RLI and RMGX to result tertiary alcohols. And next, it is a different reaction. So this RMGX as well as RLI both will give the different products. So why it is happens, or why it is so? Why? Because compared to RMGA, RLI are more reactive. Compared to RMGX, RLI is more reactive. Okay, see, let's see what happens here. Whenever RMGX is treated with carbon dioxide, that results the formation of carboxylic acid. So why? Because here the carbon dioxide, in that carbon dioxide, this carbon is surrounded by two oxygen atoms. So these are higher electronegative. So that's why the carbon acts as a electrophilic center, or you can say electron deficient center. So this alkyl part of RMGX, that is nucleophilic center. Nucleophilic center attacks on the carbon of carbon dioxide. Thereby, what happens? CC bond formation taken place. In first slide, I shown you. I told you that by using this RMGX or RLI, we can create a new carbon-carbon bond. So in remaining here, before whatever reactions we have discussed, here also see a new carbon-carbon bond is formed, and see this blue part came from our reagent. Okay, so this is used to distinguish the previous carbons and new carbons. So this is the new CC bond, and here in this case also new CC bond, and here in this case also new CC bond. So organometallic compound generally used to form, used to create a new carbon-carbon bond. Okay, so here also a new carbon-carbon bond formed, and that result the formation of carboxylate ion. So carbon dioxide is converted into the carboxylate salt, and again on hydrolysis it gives the carboxylic acid. So in the case of RMGX with carbon dioxide, this reaction will be stopped here. But where in the case of RLI, what happens? This carbon dioxide initially gives the salt like this, but this salt again will undergo the reaction with one more lithium RLI to give the ketone. So R2C double bond O. So actually it is R2C double bond O, or actually it is shown as R2C bond O taken twice, O minus. This is salt, and O minus taken twice, and 2Li. And further what happens, one the proton donor, so proton will be donated, and that means the salt will be hydrolyzed. So again what happens, we can get the ketone. So again this ketone will react with one more lithium part, and that yields the tertiary alcohol. So that means we can say in this reaction the carbon dioxide will react with 3 moles of RLI to result end product as tertiary alcohol. So whereas in the case of RMGA, this reaction will be stopped after formation of carboxylic acid. But here what happens after formation of carboxylic acid? So first what happens? We get this carboxylate ion. Here also we get the carboxylate ion. But whereas this carboxylate ion again reacted with one more RLI to give a salt of oxide, that is the dialkoxide, the salt of dialkoxide, and the salt of dialkoxide again on protonation it will convert it into the ketone, and further this ketone react with one more alkali followed by the hydrolysis to give alcohol. So this is about the organometallic compounds. Okay, so to my next class onwards we will start another new unit, so that is organic chemistry. So okay, so I will use a new device, so that is known as a Wacom. So Wacom can be used as a blackboard. So whatever I will write on blackboard spontaneously or instantly, that will be reflected on screen. You can see that screen. So by using that we can uh, discuss organic chemistry very easily. Okay. Okay, so this is about inorganic chemistry. So far in inorganic chemistry, we have discussed 3 lessons. First one is Bloch elements, second one is coordination compound, third one is organometallic compound. In that organometallic compounds, we have discussed about the carbonyls, and then this one RLI and RMGX. Okay, I hope you understood this. Okay, so with this we completed our first unit. Thank you.